Okay, so next up, we actually had a request to basically discuss kind of the two-way application with Alert 2. And so I had asked Tom Ogden, which is the hydrology senior project manager at High Sierra Electronics. And so um, thank you, Tom, for stepping up to present.
Sure. Let me get just a second. You're not seeing my screen yet, are you?
No, not yet.
Okay. That's because I didn't hit share screen. I was so excited. Okay. Okay. Okay, you got it now?
That looks good. Go ahead.
Okay, are you seeing all the, how do I minimize the?
Yeah, it looks good to me.
Okay, all right, good. Let's see. All right, so as Ron said, I'm going to be talking about Alert 2 in a two-way application for command and control, specifically how High Sierra implements it. And also want to, happy to have the opportunity, along with a few of our other AEM family companies, to be sponsoring the meeting. So just a quick agenda. I'm going to talk about what we refer to as command and control, the different applications that we use it for. I'm going to talk about Alert 2, our move to bring Alert 2 into these systems, and then give some examples, finishing up on a recent job earlier this year in the county of Santa Cruz. So when we talk about command and control, we're talking about the ability to control a remote device with the transmitted command. In this case, in the picture, we're seeing beacons and a gate. These can be activated by a master controller. We call the controlling side a master, and with a set threshold telling it when to activate any of the external or remote sites that it's been told it is controlling. And this is an autonomous system, works on its own, but it can also be activated using remote commands through base station software. It obviously requires two-way communications because we want to be able to not only send commands to a remote site, but we want to be able to confirm once we've received that and acted upon the site. We want to confirm to the master that the action has been taken, that was initiated. While it is autonomous, pretty much all of the systems we put in, with very few exceptions, also have the ability to control. Operators want that ability to send a request for status, or what we call an override, which would be a remote control from the central software. That might be a situation where maybe you have a PT that's out at a low water crossing, hasn't been replaced, and you know that you've got a condition out there that likely is a problem. So you can send an override command and put the remotes into an active state. So some of the applications, the first picture I showed there is what we refer to as a high water detection system, where we're activating flashing beacons, opening and closing gates, and we can also utilize a dynamic message sign, where we're doing a system now where we've got blank out signs and we've got multiple messages, so we can activate different signs or different messages within the sign. We can also use it to control cameras, to either remotely to activate an image and have it transmitted, and we also use it for power management, so that you know, the cameras can be pretty power hungry, so we can have them powered down and then activate them when we want. Another application we've used is sirens. These have been also flooding situations on rivers where there's a lot of population, sometimes recreational, in the floodplain, and we can activate sirens basically the same as we're doing flashing beacons based on a threshold and activating those sirens. So here's just a real quick illustration of what I just said verbally. So you got the water level comes up, you exceed a threshold, you send a command to the what we refer to as the remotes, or sometimes flashing beacons. It confirms that it's on. The master transmits to the base station, and the software gets a message, likely is sending out alerts to various people. Level goes down, the message to turn off, it responds, and again, the reverse happens, and the system is deactivated. So we've been doing these systems for about 20 years, a little over 20 years, and have been using the alert protocol, actually in a two-way. We came up with a method of using a two-way alert communication that would activate these systems, and it's actually worked very well. Some of the potential problems, you know, with alert, obviously you have the possible contention or data collision. What we found in that case is the masters and remotes are generally pretty close to each other, and the signal strength is much greater than any collision coming in. So we didn't typically experience issues with the local system activating. But if you're, say, going through a repeater, you're transmitting to a distant base station, in these cases, if you have collision, you might, even though the remote system, the local system is activated and behaving as expected, data collisions coming into the base station might be giving incorrect information. So with the advent of Alert 2, we felt we really wanted to take advantage of the advances of Alert 2, and we also believe that completely Alert 2 end-to-end solution provides the most robust system, which is completely VHF, and so that's what we set out to do. And you know, Dave touched on all of the advantages of Alert 2 earlier before lunch, and you know, obviously with the TDMA, you've got guaranteed reception, so that any of that problems with data collision goes away. Also, the data collision where you can possibly have garbled data is eliminated in part because you're not having collisions, and also the forward error correction is correcting incorrect data typically. Also allows for the sensor data, the stream levels, the GPS and battery level datas are giving you, are transmitted in engineering units, and more recently encryption, that you, especially in a situation in an application where you're controlling things, encryption is very helpful in that you're not going to have somebody, some rogue individual activating your system or deactivating it when it should be active. So those are some of the key advantages that we saw in moving to Alert 2. Obviously, some development was required because, two-way communication is going to require the Alert 2 decoding capability at every site. At the time when we started doing this, Alert 2 base station decoders were, in our view anyway, it was really cost prohibitive to put a Alert 2 decoder in every at every location. So we undertook the development of a lower cost decode capability that we could incorporate into our controller. In addition, the two-way capability in the base station control requires that you have that two-way capability coming out of the base station. So we developed an alert2 transceiver that acts as a base station decoder. It ingests all the incoming alert2 data, and it also interfaces with the base station software to accept and transmit any outgoing commands. It also presents a bit more, TDMA is already more complicated than an old legacy alert system in terms of ID plans. There really wasn't much of one there was an ID scheme, but in terms of you didn't have to plan how everything's going to have its own time slot. So having sites transmit and respond to each other just does complicate the TDMA planning a bit. But some of the TDMA considerations in fully alert2 two-way system, we determined that leaving 7 seconds between the master slot and the remotes is a good approach. The remotes can all transmit right next to each other. If they're dual masters, and I'll talk about that a little bit more, we also sometimes refer to them as remote masters. The remote master will have half the frame length as the main master. If repeater is in use, then you definitely want to, just like in a standard alert2 system, you would have the sites going through the repeater as close as possible to the repeater's transmit period to reduce latency. And also, like in any alert2 system, you want to upfront, where possible, allow for future expansion so that you're not having to change your entire system configuration when you do decide to expand. If you know that you're going to build the system out a bit later, that it's definitely good to include that to begin with.